All right, this one is on 11.4, which is they define, and these are very common functions. They're called hyperbolic. The h looks like cosine with an h. This is what it is. So this is called a hyperbolic cosine, which people pronounce cosh because that's what it looks like. However, hyperbolic sine is hard. What do you say there? So people just say sinh, even though there's no ch whatever, but it works. So cosh and sinh, and they're defined by this e to the x plus e to the negative x over 2. It turns out they're actually really useful things. They come up a whole lot. And the last part, they show an example of where these functions come up. The only difference is this one's plus, that one's minus. Okay, so part A, you're supposed to graph it, and I'll let you do that if you want to use Desmos, which is probably the easiest way to do it. Just plug it in somewhere and see what they look like and draw a quick graph. I'll let you do that. And you'll see that they're kind of hyperbolic. That's why they're called hyperbolic. And then B, what you're supposed to show is that, and then they show you this, that cosh of x squared, so all that squared, minus sinh of x squared equals 1. Now that's very similar to, normally we write cosine squared of x plus sine squared of x is equal to 1. And for these, it's a minus instead of a plus. So they're kind of similar to regular cosine and sine, which is why they're called like cosine and sine. They're kind of similar, even though they look like they have nothing to do with it. So for this, you plug in those formulas, square them. It's a lot of squaring, which is good practice. Square the 2 in the bottom, which is a 4. And just do all that stuff, and you'll find that this one minus that one equals 1. So I'll let you guys do that one on your own too. Okay, then 11.4c looks like this. I already drew the picture to get a head start here. And this is a really cool problem, and this is one way you can see where this thing comes in. This is a cable, like a power line hanging between two supports, and you want to make sure that you can go underneath it so that that distance d as it sags. And it turns out that the shape of this thing is given by a cosh. It's given by the cosh function, and so they write down that it's some number a times cosh, and then it's x minus h over a plus c, where h, a, and c are all just constants. Okay, so then we're supposed to make a coordinate system, so we can do this for x and y and everything, and it's easiest, and they suggest you put the coordinate system so like the axis, the origin is right there. Okay, so then the risk of completely confusing my picture, so this would be the y-axis, and the road here, this is the road, would be the x-axis. So that will be our origin there, and if we do that, then h is equal to 0. So that's always nice. And right, so then h would be equal to 0. So if we put the origin right there, so h is equal to 0. And if we do that, and they tell us that then a is equal to 500 in this case. So we can also say that a is equal to 500, and now we can then figure out what the other, we're supposed to figure out what d is now, what the lowest distance it is if that's the shape of our curve. Okay, so what do we know? We know that at 200, if this is 0, at x equals 200, then we know that the height is 100 feet. So that's something we can plug in. So here's our formula. So y is equal to a, which is 500, cosh, and remember h is 0. So we're going to plug in x equals 200 right here. X equals 200, because it's 400 feet across, right? So this is 200 and that's 200. So x equals 200, and let's see, a is 500. Then we know that that's plus c, y is equal to 100. Okay, so the only thing we don't know right now then is C. So this allows us to find what C is. We figure out what cosh of 200 or 500 is, and then C has to make up the difference to get to 100. Okay, so we plug those numbers in. So 500 and cosh just means the e to the formula. So then let's see, 2/5, that's 2/5. 200 by 500 is 2/5, which is what, 0.4? So it's e 500 times e to the 0.4 plus e to the negative 0.4 divided by 2. I'll put that in parentheses. Okay, so now we got to figure out what that is. What's e to the 0.4? It's e to the negative 0.4 divided by 2, multiply it by 500, and that's plus c, and that's equal to 100. Okay, so you got to plug all that into your calculator. So I'll do that right here. So I go, okay, so I'm going to show all my work here to make sure I don't make a mistake. So this is 500 times e to the 0.4. I got 1.4918 plus e to the negative 0.4. And this is again a calculator problem, so just make sure you can get the same thing. Different calculators work differently, so you gotta, I don't know if you guys brought home the ones we use in class, but you can use anything for this. Plus e to the negative 0.4, I got 0.67032, keep lots of decimal places, divided by 2, plus c equals 100. Okay, so now let's do all this math. So that plus 1.4918 equals that, divided by 2 equals that, times 500 equals 540. Okay, so I get all this stuff here, because this is bigger than 2, so it's going to make this a little bit bigger. So this is 540.53, which plus c is equal to 100. Well, clearly c is going to have to be negative for this to happen. So c then is equal to 100 minus 540.53, which is just negative 440.53. Okay, so our formula for this shape, for the hanging cable shape, is now the height at any point x is 500 cosh of x over 500 minus 440.53. That's our formula now. We figured out all the constants. They told us that a is equal to 500 because they're nice. That's just something you have to know. And h equals 0. If we use the center point there, that's like the x center, and we just made that 0. So there's our formula. So what is d now? So what is y when x equals 0? Okay, that's all we gotta know. So when x equals 0, what is y? Well, let's see. Cosh of 0, well, let's just plug that in. So we have 500, oops, that's a cosh there. So 500, we plug in 0 here for x. We want to know what the height is. So that's d, call that d, is when x equals 0. So then we just need to know the cosh of 0. So we plug in that formula again, e to the 0 minus e to the, plus e to the negative 0 divided by 2 minus 440.53. Well, let's see. That's just 1 plus 1. Anything to the 0 is 1. That's 2 divided by 2, which is just 1. So this is easy math. So this is just equal to 500 minus 4. I keep doing that. 440.53, which is equal to 500 minus 440.53, which is equal to 59.47. That's a decimal point there. 59.47 feet. So the cable is only going to be 59.47 feet above the road, which is pretty high. that's probably not going to be a problem. No truck's going to hit it. But anyway, that's the idea. Hanging cables always make this cost shape, which is one reason why they defined it as a function. And then you can, by knowing that, you can plug in the variables and you can determine how low something goes. So, okay, that's 11.4c. You can finish A and B on your own. And chapter 11 then goes really fast. And then we'll move on to chapter 12 before spring break. So, okay, talk to you later.